Hey everyone, my name is Sahil, and in today's video we will learn how to guarantee the quality of your insulation piercing connectors. By the end of this video, you will fully understand the electrical and mechanical testing required for these connectors, including the continuity test, their shear head break test, the high voltage test, tensile test, water tightness test, and finally the electrical aging test. First, let's just briefly look at what IPCs are and their usage. Known as IPCs, insulation piercing connectors are used in all AB cable systems. They create tap connections that can extend the line, distribute the line, connect to street lights, or even connect to households. These connectors come with a water resistant design that seals the connection, guarding against water penetration. Low quality IPCs allow water to enter the cable, and this can cause issues like short circuits and metal corrosion that will compromise the entire electrical system. Additionally, the connectors are designed to eliminate the need for insulation stripping. This makes the installation process quicker than in traditional bare conductors. This feature also reduces the likelihood of tampering or theft of electricity. However, to establish reliable and durable electrical connections, these IPCs need to be built of high quality. But how do you ensure quality for IPCs? The French Standard NFC 33020-2013 specifies the testing requirement for these products. In the rest of this video, we'll go through 6 of these electrical and mechanical tests. Firstly, the continuity test. Continuity is the presence of a complete path for the current flow. This test confirms the continuity of the current across an IPC. To perform this test, you can use either a continuity tester or a meter equipped with a continuity beeper. In the case of the tester, if the light glows, it implies that the continuity is proper. As you can see here, in the case of the Axis IPC, the light glowed. This confirms that our IPC is correctly connected to both ends of the cable and has properly established connections. Secondly, the shear head break test. The goal of this test is to ensure that the shear head breaks at a specific torque. This is important for the functioning of the IPC as it ensures and indicates correct installation. If lower torque is used, there will be a loose connection. If too much torque is used, it will lead to breakage of the conductor. Hence, if the torque is not accurate, it will lead to system failure. As you can see here, our IPC passed the test. Their shear head broke at the defined torque, which was between 9 and 11 Newton meters for this model. Now, test number 3, the high voltage test. This test checks if the insulation material can handle high voltages, especially during fault conditions. If the HV tester trips and the buzzing sound stops before the required time, the sample has failed. This means that the IPC could not sustain the required high voltage level. As you can see here, our HV tester did not trip and held a high voltage of 6 kV for 60 seconds. This tells us that our connector can handle high voltage levels during fault conditions. Now, test number 4, the tensile test. The aim of this test is to determine if the connector can withstand the required tensile load without damaging the cable it is connected to. But how do you perform this test? You set the tensile load value and duration according to the NFC 33020-2013 standard and then apply the load for 1 minute. After the test, you check for 2 things. Firstly, the IPC should not be damaged. And secondly, the conductor should not slip from the connector. If either occurs, the sample fails and does not comply with the standard. As you can see, our IPC remained undamaged and there was no slippage of the conductor. This confirms that the Axis IPC can handle the required tensile load. Moving on to test number 5, the water tightness test. Preventing water from getting inside the IPC is crucial. Water can easily damage short circuits and damage metals. But how do we conduct this test? We ensure that the installed IPC completely seals the connection tightly to prevent any leakage through the conductor. We submerge the IPC in a water tank for 24 hours, keeping a portion of the installed conductor within certain water level and half of the conductor outside of the tank with the same level of water. After this period, there should be no signs of water at the end of the core. As you can see, our IPC shows no watermarks or traces at the ends. confirming its durability and suitability for outdoor and wet environments. Now, the last test, the electrical aging test. The goal of this test is to assess the connector's long-term performance, which is absolutely critical for long-term use in harsh environments. We connect multiple IPC samples with appropriate cables in a series to form a test loop. We then evaluate the functional properties of 6 connectors and 1 reference conductor. This reference conductor is part of the loop, and we control its temperature to reach 120 degrees Celsius by injecting current. After both the connector and the reference conductor are heated and stabilized, they are cooled back to ambient temperature. We repeat this heating and cooling cycle 1000 times, which takes approximately 3 months to complete. The Axis IPC passes the test if it meets the standard criteria as per NFC 33020 standard for resistance and temperature, proving that the Axis IPC is built for longevity. I hope you now have a clear understanding of insulation piercing connectors and the rigorous quality tests that we perform. Please note that there are more tests. However, these 6 tests are the most important ones to ensure quality. At Axis, we ensure that our IPC is subjected to these comprehensive tests in our NABL accredited and UL approved testing lab. We never compromise on quality, which is why millions of Axis IPCs are installed across the world. Before you move on to another video, remember that even the best tests can't compensate for inadequate installation. Watch this video to learn more about the correct installation procedures for insulation piercing connectors.